Welcome to AP Calculus, Lesson 11, Implicit Differentiation. Before we talk about implicit differentiation, I think we need to talk about the difference between explicit differentiation and implicit differentiation. So, yeah, she's really annoyed. This is Molly. She likes to act like a meerkat occasionally. And I think that she is gone. Alright, now that we've got that distraction out of the way. Implicit differentiation as opposed to explicit differentiation. Most of the differentiation that we've done so far has been explicit differentiation. A function has been defined in terms of one variable. Okay, now we're going to have some expressions or equations that are not necessarily a function or are not in terms of one variable. So let's just go ahead and move on. I'll let you read this. So you can go ahead and pause it while you read it. Now when you look at this, I know you're going to be just a little bit overwhelmed. Don't be too overwhelmed. All I want you to think about is the fact that y is just some function of x where it's sine x, or maybe y is x squared minus 2x plus 1, or y is it's some function of x. Okay, y is just some function of x. All right, so what we're going to do here is we're going to look at that exponent and deal with it just like we would if it was in terms of x. 5y to the fourth. But remember that that is some function of x, so we have to do the chain rule, which means we need to take y prime. We're going to multiply it by y prime because y, remember, is some function of x. Plus this we can differentiate just like normal, 6x equals, okay, derivative of sine x, you betcha, cosine x, minus 12y squared. Chain rule says take the derivative of the inside function, y prime. Now here's the cool algebraic shenanigan kind of thing. What we want to do is we want to get all terms with y prime on one side. Yes, Noah, I am trying to stay away from that nasty corner there. 4y, y prime, plus 12y squared y prime equals cosine of x minus 6x. There. I got all the terms with y prime on one side. We're going to factor that. 5y to the fourth plus 12y squared equals cosine of x minus 6x. And then to find y prime, we're going to divide both sides by that set of parentheses, so the final derivative is cosine of x minus 6x all over 5y to the fourth plus 12y squared. And there's the derivative of y. Even though this function was not written in terms of y, we can still find y prime. Let's go ahead and move on. Alright, we'll do it again. Okay, we've got two functions of x, 3x squared, and some other function of xy. Okay, product rules in effect. So we're going to do derivative of the first one times the second plus the second times the derivative, the first times the derivative of the second. Okay, hey, I've already done this one. 5y to the fourth times y prime because of the chain rule. Okay, we have a quotient rule in effect. So derivative of the numerator, you know what, Noah? I'm going to work underneath here instead. That way I don't go over towards that corner at all. Thanks again. Y prime times 2y minus x minus y times derivative of the denominator, 2y prime minus 1 all over 2y minus x quantity squared. Alright, so are there going to be any like terms? Actually, there will be some like terms, so we'll distribute that out. 2y y prime minus xy prime minus 2y y prime plus y all over 2y minus x quantity squared. Hey, those two y primes cancel out, so we end up with y minus xy prime all over 2y minus x quantity squared. Okay, find the slope of the circle at x squared plus y squared equals 16 at the point root 7, negative 3. Okay, so we're going to take the derivative. That would be 2x plus 2y, chain rule y prime, equals derivative 16, 0. 2y prime equals negative 2x. Divide both sides by 2y. Y prime equals negative x over y. So, what is the slope? Y prime of, this time we're going to use a point, is going to be negative root 7 over 3. That will be the slope that goes through. Wow. Root 7 over negative 3, that's a negative. Sorry about that. So that ends up making it y prime of root 7 negative 3 root 7 over 3. We're just going to continue on. Next screen. Find the equation of the line tangent to that equation at negative 2, 1. Notice you have a point already. What do you need? You need a slope and a point. Let's go find that slope, okay? Product rule here, and then 3 non-product rules. So derivative of the first function 4x, y to the 5th, plus 2x squared times 5y to the 4th y prime minus, put this thing in parentheses, please. Put this product rule in parentheses. 5y cubed plus 5x times 2y squared y prime minus 3 plus 4y prime equals 0. Oh boy. 4x squared y to the 5th plus 10 x squared y to the 4th y prime minus 5y cubed plus 10x y squared y prime minus 3 plus 4y prime equals 0. Okay, get all the terms with y prime on one side, everything else on the other. So 10x squared y to the 4th y prime minus, plus 10x y squared y prime plus 4y prime equals, let's get everything else over on the other side. It's going to be a positive 5y cubed plus 3. Take care of that. Taking care of that. minus 4xy to the fifth. Factor out a y prime. And let's see here. We're going to divide both sides by that factor. I don't feel like doing two steps at once. I feel like doing two steps at once. 5y cubed plus 3 minus 4x y to the fifth all over 10x squared y to the fourth plus 10xy squared plus 4. Okay, that is when you factor out a y prime of each one of these things, and that's what we divided both sides by. So now we got to find y prime of negative 2, 1, and now we get to substitute all that in. Yippee skippy. So 5 times 1 cubed plus 3 minus 4 times a negative 2 times 1 plus 8 all over 10 times 2 squared, that would be 40, plus 10 times negative 2, negative 20, plus 4. So 12, 8 and 8 is 16, not 12. And 44, that would be 24. That can reduce down to 2/3. So our equation of our line, y minus 1 equals 2/3 times x plus 2. And there's the equation of our line. Whew. Let's move on while we can. Okay, another way to do it instead of using primes is to use the Leibnizian notation, and that's what we're going to do. Find dA dt. Okay, RH and A are all functions of some time unit. So take the derivative of the left side, dA dt, or A prime. We're going to use those though. Okay, we've got two functions of t, 2 pi r and h. Derivative of the first one, 2 pi times h, plus the first function, 2 pi. Okay, thanks again, Noah, for continually reminding me to stay away from that corner. That leaves us with 16 over 24, which reduces down to, hey, stop that, which reduces down to 2/3. So the equation of, because a y prime of negative 2, 1 equals 2/3. So the equation of the line, y minus 1 equals 2/3 times x plus 2. And that will leave us to the last screen. I've got about 2 minutes to do it. I hope I can get it done. Alright, sometimes instead of using the Newtonian notation, we will use Leibnizian notation, especially when we're dealing with time. And we have A as a function of time t, r as a function of time t, and h as a function of time t. So instead of using a prime, r prime, and h prime, we're going to use dA dt, dr dt, and dH dt. And here we go. We got 1 minute. Going to try to get this done. Minute to win it. dA dt equals, okay, product rule, 2 pi is the derivative of that, dr dt times h, remember doing the product rule, plus 2 pi r dH dt plus 4 pi r, so the first power, dr dt. And there is dA dt in terms of dr dt, h, r, and dH dt. This does conclude Lesson 11, Implicit Differentiation. Sayonara.